Obrigado pela vossa presença aqui. Este é um workshop sobre processamento de sinal aplicado, vai ser o primeiro. Isto vai ser integralmente em inglês, daqui a pouco. Agradeço a vossa presença, até porque isto vai durar um conjunto razoável de horas. Não é? Portanto, eu prevês que isto termine por volta das 5h30. Vai haver vários temas de aplicação, alguns deles com a necessidade de algum entendimento matemático mais forte, mas penso que vamos lá. Now I will start to speak in English because we have people from the Nettuno University from Italy. They are going to show also some examples of their work here at our institution. I thank them for being here today. And we'll start with João Santos, that is doing, that did some research and is doing some work on virtual instrumentation. Well, this is a very informal kind of workshop. It's not a very original research is going to be presented, but there are some hints about some work of people that are working here in several different aspects. So, thank you again, and he will start the presentation.
Okay, good afternoon for everybody, and thank you for being here. I'm very pleased for having so many students, and I prepared my presentation taking in account that probably you could be here, and this is not a topic that, in spite of being a topic that is concerned with your course, it is not a topic that it is covered on your subjects, on your syllabus. So I tried to arrange the presentation in order to give you some general view of this subject. We will cover, we will talk about what is and why we make virtual instruments and virtual instrumentations. We will cover hardware topics, some software. We will refer that there are some standards, and we will finish on the remote use, and it is connected with some needs that deal with very up-to-date topics which related to e-learning and other necessities like that. And we will finish with an example of a work we have done here in this institute. So, what is virtual instrumentation? When we have computer software with connected measurement hardware used to create user-defined measurement systems, we are talking about virtual instrumentation. The measurement system is controlled by instrument-like panels on a computer screen, or nowadays it can be controlled on a mobile device, on stuff like that. The measurement data is digitized, and it is available for further processing and visualization, and every kind of treatment we can do with computers and devices like that. So, a typical instrumentation system virtual instrumentation system can look like this. Here you have some traditional instruments that are connected to a computer. Well, this is a setup that has some years now. You can not see a TFT monitor and stuff like that. And on the left side you can see the front panels that mimic the real panels you have on the real instrumentation you use to control and to visualize the data. It is composed of a computer or some similar devices and display. It is composed of specific software with a driver level software, register level software, high-level tool software for graphic unit interfaces and stuff like that. It comprises also interconnection buses and the instrumentation specific hardware. So here we can see a model, an early model of virtual instrumentation. It was focused on a traditional instrument with an instrumentation bus that appeared in the 60s. It is called GPIB, and it keeps in use about 40 years after that. And it was centered on a specific instrument and a specific program to control and get the data out of that or instrument or set of instruments. A general model of a virtual instrumentation can be a bit more complex, like this one. And it evolved and allowed to have distributed measurement systems where we can have hardware spanning from a lot of places connected with network, and we can control and acquire data remotely. So, is that really a difference on the concept of traditional and virtual instrumentation when we think about the digital instruments that are usual for, I'd say, 30 years ago? There is no big difference. So they use the same architectural components. They have a process that digitizes the data, but on both of them. But in traditional instruments, we have proprietary processors with a specific operating system, and in virtual instrumentation, we have a standard PC or other devices like mobile devices, and the standard software that makes that PC work. Why do we use virtual instrumentation? There are several reasons. One concerned with its use. The automation of the measurement process makes it more reliable and cheaper. It lowers the costs of the overall system. It lowers the cost on the implementation. It allows reuse. It allows expansion. It gives portability between various computer platforms. We can use the same software system with small adaptation between various computer platforms, It provides an easy-to-use graphical user interface. It provides a graphical representation of program structures. It provides connectivity of several kinds. And this is important nowadays. It allows remote measurements to be made, which in research or industrial environment is very important, is paramount, but also in teaching environment, because it allows that the same equipment, sometimes scarce, can be shared by a greater number of students. And it allows students accessing the equipment with less restrictions in time. We are talking about implementation of remote labs in e-learning. It's an up-to-date subject. It started, I would say, with some prototypes about 10 or so years ago, but it is very important and of great concern nowadays that e-learning is so widely used. So let's talk a bit about hardware and see some different architectures and uses of virtual instrumentation systems. This is the traditional, the first types of virtual instrumentations look like this. So we have traditional instruments with a database that allows to connect to the computer, and we have the specific software to control and take the data out of the instruments.